Hello, welcome to the course BH6 B13E Computational Physics. The contents of today's lecture is taken from Core Python Programming by R. Nageshwar Rao. We will continue to discuss topics from Module 1, Introduction to Python Programming. In the last class, we discussed about loops, which are used to execute instructions repeatedly. And there are two types of loops, the for loop and while loop. So if you know the number of iterations beforehand, or in the case of definite iterations, you can use for loop. In the case of indefinite iterations, where the number of iterations are not known beforehand, you can use a while loop. Now suppose you want to come out of the loop before all the iterations are completed. You can do this using an instruction known as jump statement. There are two important jump statements in Python. First one is known as the break statement, and second one is known as continue statement. Let's first talk about break. It's a jump statement to terminate the innermost loop by skipping the remaining part. After termination, control will jump to the very next instruction after the body of the innermost loop. So in a nested loop also, break statement will terminate only the innermost loop. So let's see the general syntax for a break statement. Let's take the case of a while loop. So while test condition, inside while loop I have statement 1, statement 2 and statement 3, and before statement 3 I have a break condition inserted. And usually break and continue, these are associated with some condition. So you use an if statement to test that particular condition. So I have if test condition, then inside the if block I have a break. So what's the meaning of this? If the test condition is true, only then the break statement will be activated. Now imagine that the test condition here is false. So now what happens? This is a normal while loop with 3 statements. So this will be executed to the number of times determined by the test condition. This is the normal looping operation. Suppose you have 10 iterations. Statement 1, 2, 3 will be repeated 10 times, and after the 10th iteration, control will go out of the loop. Then statement 4, which is outside the loop, will be executed. This is the normal operation. Now suppose halfway through, after the 5th iteration, this test condition becomes true. So moment test condition becomes true, then the control will go inside the if block. Inside if block there is only break statement. Moment break is activated, what happens? Control will go out, it will terminate the loop, and control will go outside the while loop. So after the 5th iteration, the loop is terminated and control will go outside the loop and statement 4 is executed. So in normal operation, all the 10 iterations will be done, but when you have break condition activated, at that particular iteration, the loop stops and the control jump outside the loop. The same thing you can do with a for loop as well. So this is the jumping action using the break statement. Now the second jump statement is continue. So here the jump statement will skip the remaining part of the loop for that particular iteration, and after skipping that part, control will go up to the beginning of the loop for the next iteration. So if you take the same program, instead of break statement you have a continue statement here, and as I said, always break and continue are written along with a test expression. So usually you have an if statement. So if the test statement is true, only then the continue will be activated. So imagine that originally you have 10 iterations. So statement 1, 2, 3 are supposed to be repeated 10 times, and after the 10th iteration, control will go to statement 4. This is the normal operation. Now if you imagine that For the first 5 iteration, the test condition is false, so continue is not activated. The normal operations will follow till then. And after the 5th iteration, suppose during the 6th iteration, if the test condition becomes true, now what happens? Continue will be activated, and what does continue do? It will skip the remaining part of the loop, which means statement 3 will not be executed. Control will go to the beginning of the loop for the next iteration. So iteration 7 will follow now. So in iteration 7, statement 1, 2 will be executed. Once again, if the test condition is true, continue will be activated. Once again, statement 3 is skipped, it will go to the 8th iteration. So on and so forth. So in the case of break, the loop will be completely terminated, the innermost loop. In the case of continue, the remaining part of the loop will be skipped and the next iteration will follow. So I can illustrate this with some examples here. So let's take a program which prints numbers from 10 to 1. Okay. So you initialize the value of the control variable as 10, so x equal to 10 here, and while x greater than or equal to 1, you just print the value of x, then you modify the value of the control variable x equal to x minus 1. So this iteration will happen for 10 times, and after the 10th iteration it will come outside the loop, then you say print out of the loop. Okay. So initially your value equal to 10, 10 is greater than 1, so the test expression is true, control will go inside the loop, print x, 10 will be printed, the value is decremented by 1, then it will go to the next iteration. So 10 minus 1 is 9, 9 is still greater than 1, this is true, so 9 will be printed, value will be decremented to 8, so this keeps on till the value equal to 1. So here suppose this is 2, so 2 is greater than 1, 2 will be printed, then 2 minus 1, 1, then 1 greater than or equal to 1, yes, that is also true, so print 1, 1 will be printed, then 1 minus 1 is 0, so now x equal to 0. After the 10th iteration, x equal to 0. Now when it will go to the 11th iteration, it will check whether 0 greater than or equal to 1. This is not true. So since the test condition fails, control will terminate the loop and it will go to the next statement outside the loop, that is the print statement. So this is the normal operation. Now suppose that I want to print only numbers from 10 to 5. That is the first 6 iteration. I can achieve this using the break statement or the continue statement. So in break statement, this is how the program is going to follow. You have the same program, x equal to 10, while condition, print x, x minus 1. Now I have a particular test condition associated with break. So I say if x equal to 4, then break. Now what happens? Originally the value of x equal to 10, so 10 will be printed, its value is decremented, now x equal to 9, it will check whether 9 equal to 0, 9 equal to 4, this is not true, so break is not activated. It will go to the next iteration, 9 will be printed, 8, 7, 6, 5. Let's look at this condition. So print 5, then the value of 5 is decremented by 1, so now x equal to 4. Now it will check whether x is equal to 4. Moment this condition is true, it will break. It will activate the break statement, which means the loop is terminated. So after the value 5 is printed, the loop is terminated, control will go outside the loop, and the next instruction immediately after the loop will be executed. So you have out of the loop rendered here. So this is how you jump out of the loop halfway through by executing the break statement. Now the same result you can also achieve using the continue statement. So there are different ways you can do this program. One of the methods is you initialize the value x to 11. Instead of 10, I use the initial value 11. Then I have the same while condition. Then you do the decrement first itself, x equal to x minus 1. Then you have the continue statement. If x less than 5, continue. After that, you print the value of x. Then outside the loop, you have print out of loop. This P is capital. Sorry for that. It has to be a small letter. Okay. Now let's see what happens. So initial value x equal to 11, 11 greater than 1. This is true. So control will go inside the loop. And the first statement, the value of x is decremented by 1. So 11 minus 1, 10. So value of x is now equal to 10. If x less than 5, 10 is not less than 5, so this condition fails, so continue is not activated. Print x, value of x will be printed, so you get 10 here. So in the next iteration, you have 9, 10, 8, 7, 6, 5. Okay. So let's look what happens after 5. So print 5. Then in the next iteration, 5 is greater than 1. That is true. So control will go inside the loop. And first the value of 5 is decremented by 1. Now the value is 4. Then it checks if x less than 4. This is true, right? Moment this condition is true, continue will be activated. Now what does continue do? It will skip the remaining part of the loop, which means the print statement is skipped and the control will go to the beginning of the loop for the next iteration. So in the next iteration, x value is 4 now. 4 is greater than 1. This is true. It will go inside. Once again, the value is decremented by 1. 4 minus 1, 3. And 3 is less than 5. Once again, continue is activated. Once again, the print statement is skipped. So all the next iterations will happen without this print statement. So in the final output, you have only numbers from 10 to 5 are printed. And in the next iterations, the print statement is skipped. So this is how you can manipulate your iteration statement or loops using break and continue statements. Now you have a couple of homeworks based on these examples. So in the third program, I have taken the initial value of x as 11. So can you do the same program by taking the same initial value x equal to 10? So you see whether in some way you can do this program with this initial condition. And also another homework, for the same examples, you try to get the output as from numbers from 5 to 1. So in this example, we have numbers from 10 to 5 printed. You try to print numbers from 5 to 1 using break and continue statements. Let's discuss one more example of a break statement. So this is a popular exam question. Check if the given number is prime or not. You know what are prime numbers, right? You have numbers like 2, 3, 5, 7, 11, 13. All these are prime numbers. What's the meaning of prime number? If you take any number, you can write it as a product of two factors, right? For example, if I take number 3, I can write it as 1 into 3. So 1 and 3, these are known as factors. Now, for a number like 3, only two factors are there. The number itself, which is 3, and 1, which is the universal factor. I don't have any other factor. You may be thinking I can write 3 as 1.5 into 2. That's true. But when you say factors, we consider only the whole numbers. Okay, so I do not have any other whole number factor here. Now, in such case, where the only factors are the number itself and 1, then that number is known as a prime number. On the other hand, if you take a number like 4, you can write it as 1 into 4. You can also write it as 2 into 2. Right? So I have 3 factors, 1, 2, 4. All these are factors. So 4 is not a prime number. This is a composite number. Okay. Now, how do you check whether a number is prime or not? So we know that for a prime number, only 2 factors are there, the number itself and 1. So how do you test whether this is prime or not? You basically divide that numbers with all the numbers between 1 and that particular number. If the remainder is 0, then that number is going to be an extra factor and your original number is not a prime number. On the other hand, when you divide the number with all the numbers between 1 and that particular number, in all the cases, if the remainder is not 0, then you do not have any extra factors and the number is a prime number, right? For example, if your number is 10, you need to divide 10 with all the numbers between 1 and 10, that is using numbers 2 to 9. Okay. And you look at the remainder. So first number is 2, so 10 by 2, which is 5, and the remainder is 0. So moment you have a 0 remainder, which means that particular number is a factor, right? 2 is a factor of 10. So now you have 3 factors. 1 is a factor, 10 is a factor, 2 is the additional factor, which means 10 is not a prime number. On the other hand, if you take a number like 5, once again you have to divide 5 with all the numbers between 1 and 5, that is using numbers 2, 3, 4. Okay. So you divide 5 with 2, remainder is not 0. Then you divide 5 with 3, once again remainder is not 0. Then you divide 5 with 4, again the remainder is not 0. So in all the cases the remainder is non-zero, which means all these numbers are not factors of 5, and the result is 5 is a prime number. So this is how you check whether a given number is a prime or not. Okay. So this is the programming logic. Okay, so unfortunately programming logic cannot be taught, you can only develop it by practice, and also you need to apply your common sense or your reasoning. And sometimes you need to also have some fundamental idea about mathematics. Okay, so that's why I encourage you to do as many programs as possible, because that's the only way you can improve your programming logic. So once we get the programming logic right, the next question, how to implement it in Python platform, that's relatively straightforward, because by now you are familiar with all the tools or all the required tools in Python. So let's implement it in Python programming platform. So first thing, we need to input the number from the user end. Since we are talking about whole numbers, you input it as an integer number. So I'm going to call it as num. Okay. Now you know that prime numbers start from 2, right? 2, 3, 5, 7, etc. So all the numbers less than or equal to 1, these are not prime numbers, so we don't have to bother about that. So we are going to do our check only if num is greater than 1. If it is not greater than 1, then straight away you can say this is not a prime number. So that's the meaning of this the outermost if-else statement. Okay. Now inside, if the number is greater than 1, then you have to divide that number with all the numbers between 1 and that particular number. So how you create a list of such numbers using the range statement, right? Range 2 to num. So it will create a list of integers. The starting value is 2, the ending value is num minus 1, and the step size is 1. Okay. So for I in range 2 to num, if num modulus division I equal to 0. Modulus division gives you the remainder, right? So if the remainder is 0, then you print num is not a prime number. Then you break. Straight away you can come outside the loop, right? You don't have to check for the other numbers. If you have at least one extra factor, then it is not a prime number. You can stop your check. So you break. Else, you print the number is a prime number. So this is a simple, straightforward program. Now, if you are very attentive, you would have noticed that the else statement here is peculiar. Usually, else statement should correspond with the if statement. So ideally, I should have written it with a spacing corresponding to this particular if statement. But here, else is written corresponding to the for statement. What's the reason for this? Here the for loop is a particular loop because the only instruction inside the for loop is the if statement. And what's the meaning of this for loop here? Suppose I have 10 iterations. 10 times I am asking the question if this particular condition is valid. So the actual control of the if loop or the if block starts from here, not from here, right? So 10 times I am performing the if statement. So control starts from here. That's why else is written corresponding to the for statement and not inside the loop. Now if you follow the conventional method and if you try to write else corresponding to the if statement inside the for loop, and if you try to run your program, sometimes the traceback will give an error message saying that the spacing doesn't match. Or in some cases, you will be able to compile your program, but when you try to execute it, you will be getting wrong result because the control doesn't start from here. In this particular case, control starts from here. So you have to be careful about that. So you have an assignment, print all the prime numbers in an interval. Okay, suppose you have an interval where the user gives you the lower limit and upper limit, like print all the prime numbers between 1 and 100. So 1 is the lower limit, 100 is the upper limit. So once you are given an interval, you need to print all the prime numbers inside that interval. So that's an assignment for you. Finally, before stopping, let's learn about another important statement in Python known as exit statement. This is a built-in function defined in the module sys, and using this statement we can terminate the entire program at any stage. Okay, so before using exit, you need to first import the sys module. So you say import sys, and then you say sys.exit. So this is the typical syntax. Let's see one example. So import sys x equal to 50. If x is not equal to 100, sys.exit, the values do not match, else print validation of the values completed. Okay. So moment Python sees the statement exit, it terminates the entire program. At that stage, the remaining part of the program will not be executed. So straight away it will execute with the exit statement, whatever is printed inside the exit function. So you will see the output values do not match. Okay. And even though this is part of Python, usually you don't use it in production codes. So the chances are that you are going to encounter exit statement in your programs are very less. I just mentioned it because it is part of the syllabus. Other than that, I don't think you will be using it much. So don't bother about it much. So in the next class, we will discuss about two data types which are very specific to Python. One is known as tuple and another one is known as a dictionary. So stay tuned for that. Thank you.